Very good noon. So we are discussing about the acceptance sampling plan in the previous class. We have seen what is meant by acceptance sampling, what are the advantages advantages of sampling inspection, what is 100% inspection, and the limitation of sampling inspections. These things we have seen in the previous class. So it has laid a basic foundation towards learning the acceptance sampling. Okay. So next, we need to think how this process it goes on. So in today's class, we are going to study about how we are going to take or collect the samples itself. That means, what are the different sampling methods, how to take the samples. Because we need to understand that the success of this acceptance sampling, it depends, or the sampling scheme, it depends on how the samples are collected, that is the randomness of the samples. What this one? Randomness in the sense what? Each article or each thing has the equal probability of selection. So for example, if it is some cluster in the box, the items have been kept. If I put it like this in the box, if the items are kept, for example, if the defective items are kept at the bottom and the good items are kept at the top, what will happen? It may contain more defective items, but if it is concealed and put it towards there is a likely tendency that we are going to collect the items from the top. We may not go into below or something like that. It should not happen like that. In the real collection of the sampling, it should have the equal probability of selecting. That means we are going to take this one and say that the proper mixture will be there. Or even when we want to pick up for lottery purpose or certain things, some chits, then it should be properly mixed. That is what we say. That means each will have the equal probability of selection. That is what we need to ensure. That is randomness of the sample. That means how we'll create that situation. Okay. The next one, it depends upon the sample size. How many samples will be taken? One in the selection of random sample, this thing, and second one is what important criteria? The important criteria, the important thing we are going to consider is the sample size. Whether I should take only one sample, 2, 5, 10, 20, 30, 40, like that. And as I told you, mostly in case of statistics, we are not going to collect more than 50 samples. Then it will become large, very large sample. That is what we say infinity. And again, it depends, this sampling scheme, it depends on quality characters to be tested. What type of quality characteristic? Means what? Is it a miserable quality characteristic? Or whether it can be distinguished only into defective and non-defective, like that. That is what we exactly, yes, you are right, in the sense whether it has got variable characteristics or attribute type of characteristics. Okay, it depends on that. First three are what? One is randomness of selection of the sample. Second one is the sample size. The third one is the quality character to be tested. And the fourth one is the lot size. Okay, lot size. And the fifth one is acceptance criteria. Or if I put it in a proper way, those things will be, first is randomness of the sample, second sample size, third quality character to be tested, fourth acceptance criteria, and fifth the lot size. So that means based on these 5 factors, the sampling scheme will depend. Okay? So based on that is what I told you, one of the things that characteristics in the sense whether it has got measurable characteristics, that means variable characteristics or attribute characteristic. But in fact, to tell you here, we are going to discuss only about the attribute type of characteristics. That is, we are not going to decide about the sampling by variables, but we are going to consider only the sampling by attributes. Okay, that you should keep in your mind. That means how much, what is the degree of defectiveness we are not going to consider, whether it is a defective part or a good part. So its length should be within this much. That is what we are bothered. It should not be more than this, it should not be less than this. It should not be more than 10.5 mm and less than 9.5 mm. 9.6 mm, yes, okay. Up to 10.4 mm, okay. Up to 10.5 mm, okay. But if the moment it is more than that, no. In that case, usually we are going to use, that means classification of measurable data itself can be made attribute. How it can be made attribute? The way of inspection, instead of using the measuring scale, maybe vernier and other things, not that. Go gauge and no go gauge. Because there the things will be very fast. So we are not interested. Actual, the measured value, no. Only two things. Whether it can be classified as a good item or a bad item, or good one or defective one. Okay, we are going to be concerned with that. That is what we say attribute type of data. So usually measurable data can be converted into attribute type of data. That is what one of the examples I told you by using go gauge and no go gauge. Okay. So then next one, let us see where all this acceptance sampling will be applied in industry. Industrial, the uses of acceptance sampling. That means where all we are going to use. Okay. Okay, one simple remember is, whenever the industry is there, what it does, the industry, mechanical this thing, it converts the raw material into a finished goods of utility. That itself, we call it as mechanical engineering. In fact, that means raw material will come in and the finished part of certain utility it leaves. That means these things, that acceptance sampling or inspection sampling plan will be applied when the raw material is being, because huge amount of raw material is required, or maybe sub-assemblies are required like that, because if it is going to assemble the things and other things. That means incoming, or the stock, incoming stock, it needs to be inspected and it should be accepted, whether it is good or bad. There we are going to apply this acceptance sampling. Next one is, after this one, what it happens? It goes under process. Okay, when the process is going on, that is what I told you, in between, in different stages of the process, this acceptance sampling will be applied. That means to decide the acceptability of semi-finished products. What is one? First one is to determine the quality and acceptability of the incoming raw material. Next, when it is taken up for the process, to decide the acceptability of semi-finished products for further processing. There also we are going to use this acceptance sampling procedure. Next one is to determine the quality of the outgoing product. Now the process is over so that it should reach to the customer. Then there also we are going to apply or use this acceptance sampling. These are the three uses of acceptance sampling. One more use you can include would be for improving, maintaining and controlling. What? For improving, maintaining and controlling of the quality of the product which is manufactured, so that the organization gets the name. Okay, these are the four uses of acceptance sampling. Okay, next we'll study about how the samples are to be collected, or it is called as the sampling method. Sampling method. That means, how do you collect the samples? Try to distinguish between two things. One is sampling method. Another one is sampling plan. Okay? Sampling plan is different than the sampling method. Okay? Sampling plans are different than the sampling method. You try to understand this much only. Try to draw the distinction between these two. Sampling method, how you are going to take the sample. That is all. Why? I told you at the first this thing that it should be a randomness. That is what? You got this one? The important thing, the four things will decide these things. What are those four things? Success of sampling scheme depends on the four factors. One, I told you that randomness of the samples. Okay, that is what is important, first one. Okay, that is what we are discussing about. That we say that is the collection of the sample. Four parts we discussed, is it not? One is randomness of the sample. Second one, sample size. Third one, quality characters to be tested. Okay, that means attribute or this thing, the variable. Fourth, acceptance criteria. And the fifth one is the lot size. Okay. See, the sample size, lot size, sample size and acceptance criteria we can consider under the sampling plan. Okay? Try to understand that. That comes under the sampling plan. Sampling methods, that means how the samples are to be collected so that what is important, that means the randomness of the sample. Why randomness of the sample? I told you that each article should have the equal probability of being selected as a sample. Because ultimately not all items are going to be selected, then it will become 100% inspection. Because I am trying to drive at this point because you need to clearly understand between sampling method and sampling plan. In sampling method, equal opportunity is to be given to all the items. That means there should be a fairness. Okay? That is what is being done in sampling method. How can we do in different, because can we think about the different methods? What are the various things you can think about that one? So why is important sampling? Because whatever the sample we take up or we collect, it should truly represent all the items. It should not be a biased thing. Biased thing in the sense, what? So I'll ask some three questions in the sense, simple three questions I can ask, and I can ask three difficult questions also, depending on different persons. It is what we call it as the biasness. It is not like that. It should consist of some simple questions, it should consist of some tough questions, some middle questions, medium questions, like that. Even if you look at your question paper, it will be like that. It is the mixture of all these things. Even the subjects are like that. All the subjects are not easy and all the subjects are not tough. Okay? Or if you look at the same subject, all the chapters are not easy or all the chapters are not tough. Some are easy, some are tough, some are medium, this thing like that. It is mixture of that one. So even our life, it depends like that. Same thing. It is a mixture of all. Same thing. That is what we call it as randomness. Okay, that only the real crux, because it applies in our natural way of life, or maybe when we are learning and other things, or when we are doing certain activities. It does not happen like that. So that is why maybe if you study under the networking or something like that, there we'll find out the different times. For optimistic time or pessimistic time or normal time, like that. Same thing. So why they consider like that? That needs to be understood. Okay? So, however, let us understand that the sampling method, that means how we are going to collect the samples, it is going to affect the outcome of this particular scheme, the sampling scheme. It will make or mar that scheme itself. Okay? So most of the thing in while tender documents or whatever testing or inspecting, that is why we say that it should be unbiased selection, whatever you can think, all these things. So here we are going to discuss how to take out the samples so that it should truly represent the population or the universe. Because what is the understanding? The sample should truly represent, sample should truly represent the population. Population is also called as the universe. If so, how we can take? Okay? Now, the various methods used, because it depends on these methods, they will depend on the different circumstances. Wherein lies the ingenuity of the person of collecting the samples? He needs to decide. Or when the sampling plan is being done, these things will be decided. How to take the sample itself. It lays down certain the steps or the procedures which need to be followed. It is just like SOP, standard operating procedure. How to collect the sample, okay. For example, you want to test what is the contamination, or you want to analyze the water for drinking purpose. Now how the sample is to be collected. That's the thing. It is a flowing river. What you will do? How do you collect the sample? Or you want to find out what is the percentage of water in the crude oil, and the crude oil itself is stored in the tank. Whether you will take the bottom one or the top one or whatever it is. The best example could be the crude oil, because I'm interested in finding out what is the percentage of water, or hence the percentage of the crude oil itself. If I take the top topmost layer, then it is 100% oil only. Why? The density of oil is lesser than density of the water. Okay? If you take the bottom one layer, it is only 100% water only. So it will try to give us the misconceptions or something like that. The another example I could give, maybe the sand. So usually sand is what they call in civil engineering fine aggregate. Another name for sand from civil point of view, fine aggregate. So it will have the sizes which will be known by using the sieve analysis. But usually we want the higher this thing, better it would be in the case of sand. If it is smaller, like crystals or something like even the sugar, if it is a more crystalline form, it is valued much. It is almost powder form, it loses its significance. Same thing is true in case of sand. So intelligently what they do is, okay, in the truck, if you want to buy the sand or something like that, on the top layer, they will have put, first they will have put the powdered form of the sand, starting from that, and the top and the side and other things, they will have put the coarse sand, not the fine sand. So that our tendency is, test it from the, look at from the top, see, this has got good. And how the samples are to be taken if it is to be tested. Okay. The next one is, okay, the hardness is to be measured. Then stack of steel things are put, sheets are put. Then how do you test them? Which one is to be tested? How it will be done? What is to be done? Or cement for strength or whatever it is for other its quality characteristics. Will you put it in a bag form? What is the way out for them? Okay, some raw materials, some grains. Or usually for, even if we want to buy some vegetables and other things, the top layer, they will have kept everything good. Bottom layer or middle level layer, they will have kept the worst things. So when we want to buy these things, we need to think about that. We'll mix them in a proper way. If it is smaller container, yes, we can mix. If it is a large container or the vast, what is going to happen? So that is what we will be discussing about these sampling methods. That means how to collect a sample. The first one is simple random sampling. What is one? What are the different sampling methods? I told you, different sampling method. First one is simple random sampling. It is general. Okay? It is kept in the box. You just small these things, you just mix them, pick up. Or close your eyes, pick it up, like that. Or if they are numbered, okay, just mix them and then refer random number table or whatever it is, item number 5, pick up that. Okay? So simple random sampling is, that is what we mean. What is one? If they are small numbers or whatever it is, we can pick up like that. It depends on the lot size. Okay. However, I am going to discuss about that one, lot size, sample size, and other symbols and other terminologies. These I can call them as acceptance sampling terminologies. Okay? Because frequently we are going to make use of them. Okay. So here, that is what we said, the main important factors are one, apart from random sampling, another thing is the sample size and the lot size. So these random sampling of requisite samples will be taken in a random way, just simple. This is simple random sampling. The second one is stratified sampling. Stratified sampling. So in case of our engineering goods, okay, fine, this will work. The small these things or the fruit vendor or something like that, we can see, or vegetables, we can pick up. Even in industry, okay, we can use this. But this is what is meant by a stratified sampling. It is not presented only in a small box. It is in huge number. Then what you will do? Different strata. Just like, that's what I told you, water samples or oil samples, like that. Or the sand samples, like that. Or the huge number of components of the similar types are kept. What will do? These are the things. So in that case, it is stratified sampling method. Stratified means what? Proportional. Proportional sampling. Proportional sampling in the sense of what? Because it is in huge quantity. So it has got top layer, side layer, bottom layer, middle layer, like that. What I will decide? I will decide from top. I will take some 3 these things, top layer some 3 or 4, middle layer I will collect sample of 3 or 4, maybe in these things, okay. I will make some groups, that means some 4 groups at the top, 4 groups at the bottom, 4 groups in the middle, some 2 or 3 groups in the side, either side or 4 sides, like that. Are you able to get this one? So I'll make them the group, or I will make them the lots. That is proportionate, in tune with what are the total number of items here. Are you able to imagine this one? That means, say for example, you can think it is the sand or whatever it is, the items are collected like this in huge quantity like this in this box or something like that. It is kept all. One way is what? Pour it, mix it, this thing, then take it. So it requires a lot of time. Putting it back or something like that. Okay? Because why I am trying to explain this one is, you should not get confused with the cluster sampling. Try to understand. There is not much difference between stratified sampling and the cluster sampling. Okay? You should not get confused during that time. Okay? So here, like that, that means what? Here I will make them into group. Because the total lot, this one is the lot, it is divided into sublots. What is happening in case of stratified sampling? The entire lot is divided into sublots, like this. and from each sublot, the samples are taken in proportion to those sublots. Try to understand or distinguish this one. Okay? So having done that one, that means it will give a fair opportunity now for all. Because various strata it has been collected and then it has been made. What this one? That is what is being done. If you want, you can note down these things. From each sublot into which the inspection lot is divided, a subsample should be selected, and the size of the subsample should be proportional to the size of the sublot. Okay? Should be proportional to the size of the sublot. Okay? You got this one? That means what? From the lot, we are creating the sublots. And from sublots, we are taking the samples. Those will become subsamples. And all these samples will be mixed. And from there, I will be taking the desired number of the samples. Is it understood? Okay? That means, say, for example, I have divided into some 6 sublots. Again, from each sublot, in proportion, I will divide it into 1/6 of that one, whatever it is. And then I will collect the samples. These number of samples, subsamples collected should not be less than at least 2. Okay? Now I have got some sublots of some 8. That means from each sublot I will be collecting 2 samples. That means totally I have got a sample size of 16. What is one? These 16 samples I will inspect. Those things. Which will, I feel that they truly represent the universe. Entire universe for us, or population for this one is, instead of inspecting all these items, I'll be inspecting this. This is what is called as stratified sampling. But the random sampling is not possible because of the sheer number of the whose quantity. We are going for that. Okay. Next one is, third one is systematic sampling. Okay, we want to inspect. For example, that is what I told you, cement bags. I want to test it. Because you might be knowing the test of the cement is to be carried out. But you would have supplied some 1,000 bags of cement. But I want to test, if I want to test all, if I open up all these cement bags gone, then I cannot store them properly. Then how it is to be done? Or in case of the sheet metal, that is what I was talking about. I'm interested in finding out what is its Rockwell hardness number or whatever, something like that. How do I do it? I want to find out the hardness. What should I do it? So there, the systematic sampling, it comes into picture usually. What it will be happening is, it is just like the selection of random number from a random table. You know how to use the random number table? Because this random number table, it consists of the numbers like this, randomly. But how do you do this one? Select, generate the random numbers from the random number table. See, the thing is what? Here the crux is, if you want to use this random number table for generation of random number, of course, nowadays the computers are there for generating the random numbers. It might have lost its significance, but yet I think it is a relevant example at this point of time. Okay, what we'll do is, random number table, we enter it in a random way. For example, I'll close my eyes and go to this particular line here. Once I go to this one, and then continuously I'll read. I'll go in a systematic way. Once you enter the random number table randomly, but afterwards you have to go systematically. The same thing happens in systematic sampling. First one, I will decide by randomness. Okay, I am going to, because it might be coming in the, as per the time, in periods, time-wise. Let me see. Okay, I will decide that 11:05 I will inspect first. And afterwards, every 30 minutes or every hour, I will go on inspecting the cement bag or the sheet metal, like that. I can fix every 45 minutes, every 60 minutes, every 75 minutes, like that. But first one, I will select randomly, okay, at 10 o'clock, not 11:05, 10, not 8, something like that. Afterwards, it will become systematic. It is almost similar to, this is what I told you, random number table. So this is what is called as systematic sampling. Is it understood? Now, three things we have covered. Fourth one is cluster sampling. Because that is why I had to distinguish this cluster sampling and the stratified sampling. The stratified sampling is also called as the proportional sampling. Don't get confused. I explained a bit more. Now it will be helpful for us now. So, which distinguishes it from the cluster sampling? Okay, you try to think, because I'll try to give some example, live example. You're interested in buying some nuts and bolts. Some nuts, let us assume, nuts or bolts. Well, these will be bought in thousands of quantity. Okay. So when we buy from the person, manufacturer, say 1 lakh, okay, 1 lakh bolts have been bought. So all 1 lakh bolts, you will keep it in one box and send it to us. What you will do? What is the procedure? Okay, depending upon the sizes of these bolts, because One more this thing, if you are